Alright, what's up guys? In this video we're going to pick up with some more calculus here. This is going to be integration practice video example number 6. So let's go ahead and do this next one here. Alright, so we need to evaluate the integral x squared times cosine x dx, or cosine of x dx. So we have a product of two different functions, so we're going to apply integration by parts. And we can also easily see that integration by parts here to evaluate this integral completely will be required twice, because if once we do it once, it's going to reduce the power of the x down to just 1, and we'll have to do it again. But you'll see this once we get started. So remember, integration by parts formula just comes from the product rule. So it's going to be the integral of u dv is equal to uv minus the integral of v du, or rather I should say it's derived from the product rule. And basically what you do is you determine what is an appropriate u, and then dv is everything else. So I'm going to pick u to be x squared, then that means that dv is cosine of x dx. So that means that du is 2x dx if we use the power rule. And then to get v, we integrate dv, so that's the antiderivative of cosine of x dx, which we know is positive sine of x. You don't need to add a plus c there, we'll add a plus c at the end. And so, much like I've said before, you should be doing this with every integral, but more specifically with integrals there, you have to apply integration by parts multiple times. Make sure that it's nice and neat, because you're going to have to go back and get the information from the first by parts. And so if stuff is all over the paper, you will probably get lost quite quickly. So just make sure things are neat. Well, you should be being neat anyway, but just giving you a warning on that one. So I'm just going to pull out the constant 2, and then that means that on the inside here I have x times sine of x dx. That's the next integral that we're going to evaluate. And much like I told you at the beginning when we started, notice we're going to have to apply integration by parts a second time, because like I said, it's going to drop the power of the x down to 1, which it did here. And I said this in the last video, but I'll just kind of give you just some more general examples of integrals where if you see something like x squared times e to the I don't know, x dx, that'll require integration by parts twice. The next one, ln squared of x, that'll require integration by parts twice. There's all kind of examples out there where you have to do it twice. Okay, so let's do it one more time. We need a u, we need a dv, and I'm not going to deviate much from the selections that we had at the top. I'm going to pick u to be x, and that means that dv is everything else. So dv would be sine of x dx, and then that means that du is dx, and then that means that v, we take the antiderivative of dv, so that's antiderivative of sine of x dx, which you know is negative cosine. And then we go back and we get everything in there. So this will become negative x cosine of x. Two negatives will give me a positive, so this will become plus the integral of cosine x, or cosine of x dx. That's what we get when we do the second by parts. We know that the antiderivative of cosine of x dx is positive sine of x. So if we go back to the fact that we had our 2 out there, and then don't forget that it was negative. Well, it's negative because there's a minus there. So this would be negative 2, and then we'd have negative x cosine of x plus sine of x. That's what would be if we did the second integration by parts. So really all we have to do to finish this integral up is expand this side out and just attach the left hand side for the first integration by parts we did to get the answer. And that's pretty much all we have to do to get the final answer. So I'm going to go ahead and write down the final answer down here, and we'll pretty much be done with this. So some integrals will require a particular technique more than once. So it's important not to assume that you're doing anything wrong just because an integral may require a technique to be used multiple times. Have some confidence. Make sure you go in and say, hey, yeah, I know this. You know, it might require integration by parts twice, but Don't allow that to scare you off and think that you made the wrong selection in terms of a technique. It's just some integrals are just like that. So we're going to just get our answer. So the answer here is going to be x squared times sine of x. I'm going to expand out that right-hand side over here. And it's going to be plus 2x times cosine of x minus 2 sine of x. And then I'll add a integration constant to the end. And that would be the answer for that one. Alright, so I'm going to circle that so you guys can see it. And that will be our answer to this integral. So that is example number 6 for our integration practice. So let me know if you got any questions about it. I'll be more than happy to answer it. I'll see y'all next time.